For me, all right. Let's kick this off. My name is Andre Scholtz. I'm sure.
I'm supposed to introduce him, but I'm going to let him introduce himself.
You've done a better job. I lost my bloody name.
Go for it.
All right. My name is Andre Scholtz. I'm the subject matter expert for the inside salespeople for Solarcraft. I think most of you know Solarcraft already. Is that right? Yes? Like this?
Yes.
Okay, good. Because
Yes.
the premise is we don't lean on the sales portion of it because that's a waste of time. So I'm not going to go through how fantastic we are because you know it already. I will, though, just pick through a couple of photographs in the beginning of what we build because during the class I refer back to it. In the interest of saving time, I'll get right back into it. Did I miss something, you think?
No, we're good.
All right.
Except you're supposed to tell your PhD, MS, and BS.
Oh, it's all BS. There's no MS or anything. I've been working at Solarcraft now for, I think I'm in my 8th year now. So the company, when I joined it, was about half the size it is now. And really all the information that I built up on panel building I got in Solarcraft. So I've got educated in physics and computer science, but no PhD. I'm sorry, Jim. I know I'm Andre.
Yeah.
All right. So what I'll go over quickly is just a quick introduction of our company. Like I said, rather than me talking about it, I'll just show you photographs and you'll get a good idea of what it's about. The big problem out in the field is automation people in general are very clever in making systems that they think of everything to automate stuff working in the middle of nowhere. And the highest failures happen to be in packaging and powering this stuff. So I know especially for this electric utility that I visited last week, they had 250 truck rollouts to failed panels, and 80% of their rollouts were failed panels in the power went down. What the hell went wrong? Get in the truck, go and check it out. Huge problem for people. So over the course of 7, 8 years, maybe only the last 4 really I got useful. I've been collecting all the problems that I see. Of course, I build it into the designs at Solarcraft, but it's handy to go to people and go, here's what you got to consider. Otherwise, your fancy $15,000 PLC assembly is going to fail because you put a $25 power supply in there, and here's why you want to consider that. Because a truck rollout is like $1,000 minimum. It doesn't really get cheaper than that unless it's like next door and you got to waltz out to it. Get yourself a badge. Load calculation is a problem when people design panels. I'll go through that. Battery autonomy, battery charging, low voltage disconnect, battery health. It's a lot about batteries and battery charging and load sizing. Load sizing is a critical issue. People typically don't consider it. We'll go over it here. Knowing just 3 or 4 key little takeaway pieces of information will probably be more valuable for me than laying out a huge amount of data and you can't remember anything. So my guess is, unless you guys don't speak a word, we'll probably get up to 9 batteries. So that should be enough. Please feel free to ask me questions about the stuff you see over here. That'll go better. All right. You know our company, so sort of, we're about 24 years old now. I have a big fab shop. We make panels, power systems. We build enclosures, houses, analyzer buildings. Big deal, pretty shop. it is now cleaner than you see in that photograph. This is a typical panel for us in somebody's way. Building a PLC, putting it in an enclosure that we know we can go put out in Midland, and it'll still run 20 years from now. That's the key. Nice middle of the road system for us. Sometimes it has solar panels. I must say that our name says Solarcraft, but we don't put solar on too many things anymore. It's now mostly assemblies like that. This assembly has a DC UPS, and you can check from the laser whether my hand shakes. Anyway, there's a DC UPS in it, so this one has a line feed into it and a solar feed. Don't need the solar panels. People go, just for the hell of it, just put it there, then we're a little bit more sure. We'll get to that. Same system. This one over here, the client would put their own stuff in it. That's for Halliburton. They put DTSs in them, and we just give them the empty boxes like that. This picture again, because it's awesome. More of the same. These are backups for DC actuators. Good for standing in North Dakota on both sides of a river. 15 years later, that thing will still work. Very well thought out. We make them in every flavor. Trailers, we don't like them, but we can make them. Big old skid system, offshore systems, more offshore. This is a solid oxide fuel cell for places where the sun doesn't shine in winter. You can't really go put up solar panels. There's no line power. What you gonna do? There's no energy out there. What's that?
Solid oxide?
Fuel cell. Yeah, it burns propane or natural gas.
Yeah.
And
self-generating as the gas flows. Yeah.
What's that?
It generates power as flow of gas going through the fuel cell.
No.
Yeah.
Well, yes and no. It burns.
It's relying on actual flow. If it goes stagnant, it's not producing any.
No, that you're talking about is a little inline turbine where there's a pressure differential. That's not that. That one burns and it's got a stack.
Oh, okay, it's a thermal generator. Oh, okay, thermal generator. Okay. Similar
Similar
to a
thing.
thermal
Yeah,
generator.
yeah.
Okay.
Close enough. You give the gas, charges batteries.
Yes.
Bob's your uncle. All right. A typical system for us for well control. I mean, you could use the same logic to build this. You could put in bloody any control assembly anywhere.
I got a question. Is the solar panels above that cabinet, or is that for shade?
That's for shade.
Okay.
There's the panels for this system. This one draws like a steady 50 watt. We measured it at. So just to keep 50 watts, so we can absolutely guarantee that 50 watt will stay up. That's how much solar panel will do. The people often go, 50 watt, I'll put a 100 watt solar panel. It works maybe here in the heat of summer, but when winter comes, it's dead. And then people go, solar's crap, but it's not. You just got to size it properly. We make these little buildings. We make an awesome analyzer building that has unistrut everywhere, so you can hang anything on the walls, inside out, in the ceiling, without drilling into the walls. Look into that. You probably need one. Fancy stuff. We're not allowed to mention company names, are we?
Yeah, it's nothing. But it's 316 or 304.
That's 316.
316.
Yeah.
Yeah, 304 is usually offshore.
Yeah, these are actually standing in Romania.
Really?
Yeah, somewhere in Romania. It's like in the middle of nowhere.
Somebody want to spend some money?
Yeah, that's right. Oh, they bought a lot of these. We power it with one of these. It's a compressor that we run solar powered, and it's a pneumatic hydraulic actuator. So we use a pneumatic motor to keep a hydraulic accumulator pressurized, and that runs the valve. I guess they don't want any fires or something silly
water
like that.
freezing.
Yeah.
Probably it's to prevent having to use compressed air, because you can freeze lines.
I guess.
Your water will accumulate in the line, so if you use hydraulic, you don't have that.
Right.
Conditioning
Got
problem.
it. That guy looks like he's about to steal it. He's really short, but System's about this tall. It's not very pretty. This is a PLC SCADA assembly for electric utilities. They have much the same needs as the oil and gas people. That lady built that thing. She's awesome. She built
Is she
these
really
also.
short too?
What's that?
Yes.
She could go right in that box. It's very tempting. It's Denise, man. She's so awesome.
Y'all's panel designs, are they, I think, if I remember correctly, y'all do them across any platform, whether it's rock, control wave, y'all got them from different platforms?
Oh yeah, very much. We don't really push any of them, but by now we know many of them.
Yeah, you spec them out and wire it up.
Yep. Yeah. Ideally, people would come to Solarcraft and go, here's the PLC, the radio, the switch, and the stuff I need deployed over there, and we'll do the drawings and the layout.
Yeah, because it's come such a long ways now, because I had this conversation with someone with Solarcraft. Back in the day, we used to pre-wire everything at the shop, and then in an Elden box, and then you just pull that back plate off and come and transfer it back to the site, so you're not doing that in the sun.
That's right.
Yeah, but y'all do all that for us now.
Yes,
Takes a lot of work out of it.
that's right. Yeah. And so on and so forth. All right, so jumping into UPSs and UPS design then. So about 2 years ago, right about this time, the end of winter, I was in Mexico with our boss, and we're running around doing all businessy nonsense, and I got a call from the same Halliburton people over there, which I now know I can mention. And they said,
Whereabouts?
what's that?
We're in Mexico.
Oh, Guadalajara is where we were.
Yeah.
We were more sampling the food than we were doing the business. It's, you know how that goes.
Right.
So anyway, I got a call from this guy from Halliburton, and he's in Fort Collins, just north of Denver. And he goes, they have 11 panels of ours, and they're failing. And it's like -30. It was the sun cold snap. And it wasn't a complicated panel. Looked like that. It's not that, but it looks like that. It's just a little skid with a box, and they put their little analyzer logger in the panel, and there's a radio and it's really just that. And they go, they can't communicate with them anymore. What's wrong? So I'm sitting there going, okay, how much money did we spend on this? How much money do we hope to spend with this company? And how far is it to the airport? What does the ticket cost? And by that evening, I'm in Denver, and by the next morning, I'm in this deep snow trudging through the thing, trying to find out what went wrong with the panel. And I discovered, okay, the solar charge controllers, they'll jack up, if it gets really cold, they'll jack up the voltage over 30 volts. And everything in that box was just 10 to 30. So I'm the idiot who designed the box in the beginning. So I'm going, damn it, and I'm cussing into the snow. Because now I gotta
stayed
go.
in Mexico and got a margarita.
I
A lot
should have,
cheaper.
yeah. I took the margarita with me to the snow, but wait, talk about that. Anyway, so the fix was take a DC to DC converter, tie the voltage down to 24.0. There's an inefficiency with them that I had to recalculate the solar array. But it's another one of those things I can tick off and go, okay, lesson learned. If it gets bloody cold in a place, please remember the voltage is going to go over 30 with a solar charge controller. So I now get to stand in front of people and go, what you can learn is you don't have to spend that, $7,000 to get yourself there in embarrassment and parts and people cussing you out from the side all the time, if you just knew that. So if you're going to build a panel, there's one little dumb thing you can remember that is going to make all the difference like that. So I collected a bunch, found this well, it's the following couple of stuff with batteries, battery charging and load calculation, which I'll go over now. Do you have any questions for me at this point? Take that as a no. All right. Okay, so why'd you put a UPS? Most UPSs in the world does just that. There's the power fails, the generator is going to start up, you need to bridge that gap. And sometimes it's 10, 20 seconds. In outdoor panels, not so much. Most UPSs, you just go to the shop, you buy one, it's real dumb, you put it down, plug it in, it beeps, after 6 months you replace it. Custom UPSs for field equipment is a little bit different. Somebody's got to look at what's in there, what needs to be powered, where to go, and stuff like that. You want a UPS system for your controls. I think that's a Kinder Morgan one, isn't it?
Looks like it, looks like it.
Yeah, the flow.
Redundant power supply.
But, right. Yeah, with two of them. That's the PS2. You want your UPS to at least let you know something is wrong. The decision you got to make, really, at the end of the day, from all the notifications and alarms and logs and stuff, is do you have to put a dude in a truck that's got to go roll out there and charge batteries, or do something dumb, maybe take other batteries because the design failed? That'll be the reason for it. So you wanted to tell you. It's handy. I mean, if you really did it properly, you wouldn't need notification on the UPS, right? Just for the health of the battery system. If you want to be stingy, you go, all right, we want a 6-hour backup or 2-day backup, but this thing's on the top of a hill in the middle of nowhere, now it's a helicopter flight or a 2-day truck ride or whatever it is, it always varies. So you got to add that time to your system backup time, right? If you, a battery itself is a really, really good power quality filter. If you run something from a battery, you can have the lightning striking all over near the thing if your lines aren't too long. That's dead solid, ripple free.
It absorbs the AC ripple.
Yeah. It charges from it. It's like really good.
Especially with a lot of the instruments that we look up now, like let's say like the ABB type power systems, they're portable chromatograph units. They're very sensitive to AC ripple and things like that. So, because they operate on a low DC voltage. So we learned that years ago, but putting a battery in between, it knocks out that AC ripple.
It does, yeah. It's like putting a pond between your faucet and the thing running at the outside. That'll be steady no matter how much you open and close that faucet. All right. So, why did it fail? Well, you design the system, you spend more times doing the logic on this controller, designing the panel, stuff that you did on the calculating the power draws. Likelihood is the system is not going to fail because this went wrong. It's going to fail because this went wrong. So did you calculate the power enough? Do you know exactly what's drawn there? Did somebody else come, do I get to it, and add a little something in it? Like you leave the company, another guy goes, oh, there's the UPS, it's add a different switch or change the duty cycle on this thing reporting, add a bell and a whistle and a fan. It cooked. No, worth it to consider the temperature limits of the equipment. I see too many panels where you open the door and there's a fancy charger that'll do 70 degrees, but then there's like a household network switch, office one in there, that's good up to about room temperature. After that it just smokes. Keep in mind, the more money you throw in at the front end, the less money by a factor of 20 you have to throw it on the back end. So something like a what do you call it, little DC fed PoE injector, maybe $200 for the vanilla flavored one, and maybe $400 for the high temperature one, and it'll go up to 70 degrees. Buy that one. It's just conformally coated, maybe tested to death. It's good stuff. Just temperature rating is a good indication. Power supplies are finicky. It's probably the weakest component in the assembly already. Don't buy the cheap stuff. Buy the good stuff. So saving $100 on the front end is an extremely expensive mistake to make. I know because we play in that space. Solarcraft stuff is not the cheap option. There are people who will always make it cheaper than us, but it's cheaper to own our systems than it is to buy a cheaper system. Am I saying that right? Yeah.
Ownership.
You know what I'm saying, right?
Ownership maintenance.
Ownership. Thank you very much.
You get what you pay for.
But you were saying
Yeah.
70 degrees
70 is a very common.
centigrade?
That's right.
Yeah.
Celsius.
Yeah,
Oh, this
Celsius, that's what we have.
This is mercury.
That's
You gotta
right.
adjust.
Get over the math.
Yeah, it's 100 and it's stupid. It's like ooh, 140.
Plus 32.
135, 140.
There you go. All right. So corrosion is a huge problem because you get an enclosure. It'll say NEMA 4. NEMA 4 box is not a sealed box. It's NEMA 4 is a hose rating. So this size nozzle, this much pressure over this much of a distance, will it leak? We certified to manufacture NEMA 4 boxes. So if we make big ones, we take the smallest guy, which happened to be the guy who looked like he was stealing a compressor, put him in the box with a flashlight, hose this thing down with our calibrated things, hell of a noise, so he's got earplugs in, and then he checks for leaks. Because he can hear where we hose it.
That would close the door.
Yeah. If you hose too long, you gotta get another guy. Open the door. Get another guy.
Forgot about you. Sorry.
The little blue man. All right. So what happens is when you have a NEMA 4 box is fairly tight, but it's not sealed, right? So a terrible condition that is a problem for us that we've learned to overcome is you'll have a box standing in the sun, and it's this sort of thunderstorms that you get around here that kind of moves over the place, and then it buggers off this way, and another one comes 2 hours later. So the hot box is standing there, suddenly there's cold rain passing over it and water. And if you have any experience with a gallon milk jug standing outside, the volume changes pretty quick on a small, or the air volume, on small temperature differences. So now you're running water down the seals and you cool the box down and the box goes, and it just sucks through the seal. And then the sun comes out again, but it's too late, the water's lying in the bottom of the box. And then that water sits and it just rusts up all the cheap stuff in that box and it fails. And water's gonna do that, the box is gonna do that. You better know that that'll happen, so spec the right equipment, have things with conformal coatings on them. Really have to consider every component, every little screw. Do they have rusty screws on the terminals? If you buy the cheaper terminals, you save $50. Probably not a good idea if it's outdoor equipment.
Does Solarcraft make a Class 1 Div 1 cabinet?
No.
It's all
That's
Class
something
1
you
Div-
gotta cost.
So is this all gonna be Class 1 Div 2 or
Yeah.
NEMA 4 rated?
But you can put a wire,
What?
air, if you have air around, or,
You purge it?
purge it.
Yeah, you can purge it.
And make it,
The Class 1 Division 2 is not related really to the enclosure.
Right.
You can do Class 1 Division 2 in an open panel, drill a hole in it.
Right. No, just special applications where you're limited on space, sometimes
Yeah.
you're still within the footage and, we've run into situations like that. Sometimes you don't have like for Kinder Morgan it's 35 foot
35.
for Class 1 Div 2. I'm sorry,
Okay.
Class 1 Div 1.
All right.
Yeah.
You mean
Yeah.
35
Yeah,
foot
35
from
feet. It used to be
From the
15
pipeline.
Pipeline.
35 feet from open?
from a possible
gas.
source, any source.
It used to be 12.
Yeah, well,
Plan.
for us,
Was it like
for
5?
years, it used to be, well, for Class 1 Div 1, it was 3 foot, and then our Class 1 Div 2 was 15.
Mm.
And then when we, over the years, through company transition, They reevaluated that and they came up with 35 foot.
Yeah.
So that makes it especially hard when they go to, sometimes the landmen don't buy enough land, and by the time they lay out the piping, your nearest flange source is, you don't make the distances. So I was just curious if they made if y'all made a cabinet setup, or if it fell within that criteria, it's to be rated, you know, for the classification.
Is that fairly new?
For us?
Yeah.
Since we merged with TGP, so that was 2012.
With who?
Tennessee Gas?
Oh, okay.
Yeah, when Kinder Morgan, Tennessee merged. Yeah.
Class 1 Lift 2 is by now easy enough. The explosion proof is
Right, yeah.
you do it. I want to do it. People just
It's
refuse our
something that's,
quotations.
it's still an ongoing discussion, I think, in a lot of ways, but I was just curious if y'all have run into that or not.
Not the kind of footages you're
Yeah, yeah.
talking about.
Right,
That's
right,
new to
yeah.
me. If it's Class 1 Division 2, by now it doesn't really add much cost for us.
Right.
We got to make sure that the equipment in the box is
Well, in a Class 1
rated.
Diff 1 situation, it would, because the enclosure would be.
Then it's the enclosure, yeah.
Yeah, that would
Right.
be, Jesus.
Right,
Yeah,
but
yeah.
you could, you much, or what the ratings of the equipment inside
Right.
has to be as much more liberal than
Right.
Class 1 Division.
Yeah.
You just bolt it tight so when it pops, the fire doesn't get out. Yeah. It's
Or
so
you-
funny.
Or you have to go intrinsically safe on everything that's in there.
Yes.
Yeah, so.
Yeah.
Yeah,
It's so-
unless it's, you know, like the gentleman mentioned, that it's purged with an inert gas or something that, you know,
Yeah.
prevents
Yeah.
ignition.
We do that all the time.
Yeah.
Yes, sir. And we build the best of it.
No.
Yes, sir. Right? Right. Okay, so moving along. What
Yeah,
could
if you could do it.
be
Yeah.
surprise draws that you don't consider when you make a UPS? It's easy for people to go get a device that can, you know, pull off the trick that you need it to, but it has an AC power supply, you know, the little bricky in the wall thingy. So you go, oh, what I'll do is I'll put a power supply charging a battery, I'll put an inverter in there, and I'll power this AC device. Meantime, the brick jobby has a DC output. Skip all that, make it DC. I'll discuss here a little bit later why. Actually, I'm getting ahead of myself. Heaters, like what you find in, we were just talking about cameras, they often put a little anti-condensation heater in cameras, or valve actuators have that. Other stuff that you work with, it, I may not know what it is. And people forget how much power they draw, or when they draw it. Solenoids, it's tricky. Now you've got to spend 10 watts on a solenoid, just standing there holding something open for 10 watts, and you put 20 of them. There's ways to address that. Duty cycles is an issue. We were talking to a guy in the booth across from us who was going, well, this battery in this thing over here would last 7 years if you pull, you know, once every 10 seconds or 10 minutes, whatever it was he said. But people come and go, oh no, we need it much better than that, every second. So you may need that when you stick the acid in to get, you know, that sort of resolution for 2 or 3 months maybe. And then you're going to learn how this thing operates, and by then you can take, say, a pressure reading every 10 minutes or so, and you'll be just fine. But if you forget it on there, it's going to run the battery down when the power fails. If it's a solar power supply, yeah, just phone me. You know, we'll work over that.
That's definitely something we've run into, because the duty cycle for us, because of our gas control, our major site deliveries, where we have what they call SR points. Basically, we have to monitor pressure because they're mainline pressure.
Right.
So they're pulled every 2 minutes.
Yeah.
So, and if it's a remote site where, you know, you have to monitor that pressure, that's where we run into situations like that.
Yeah,
so-
yeah. It's something to consider. It's wider than you think. Like even a radio, if you gotta then transmit that data and it gets stored and logged somewhere else where people in suits look at it, that radio takes maybe 6 watts or so to transmit, depending on which one it is. But to sleep, it is only half a watt. So, okay, do you budget for 6 watt? Do you consider in your battery sizing that that's how much it's going to pull continuously. It may not. Your battery bank may be oversized. Panel expansion, huge problem for everybody. You come back 3 years later, some dingbat put another radio in and he hanged a little light on the thing, and now there's a light switch in the door, and I don't know, stuff. And then the power fails, the UPS goes on, and the spec in the beginning said this is a 12-hour UPS and it only lasts an hour, and nobody can even get to it, and the stuff goes down, and all the beautiful designs out there. All right, lights are a problem. I mean, they're nice to have at the site. People forget them on. You go during the day, open the cabinet door, close it, maybe not that tight, leave the latch for the next guy who's going to come in 2 hours. He doesn't come because it started snowing, the light burns, and the thing fails. All right, how do we deal with them? All inverters, the good stuff, have a little dry, no voltage contact that you can just, from the PLC, if you have one little discrete output, save it for the inverter. Then the inverter on, run your load, especially if you do AC valve backups. Operate your load, shut the inverter off. He'll live longer anyway. Oh, rotary times. I saw one on the wall over here. That's a handy thing to put. If you like in the panels for Kinder Morgan, there's the receptacle over there. If you have a remote panel, you don't want to leave the inverter on, because just leaving it on is already a 20-watt draw, just for nothing. It's just on. So you put a rotary timer there, you can plug in his laptop and his hairdryer or whatever he does out of the panel, and if he forgets it on, it's just going to run down and go click, and it's off while he's already making dust down the road. Heaters, they can be disconnected. You get really clever little, what do you call these hygrometers? They go, is it really humid? Do we really have to burn that heater? How humid is it? Is this humid? Is this cold? All right, turn on the heaters. Now it's justified. But burning them all the time, massive waste of power, especially if there's a very limited power budget, or small battery banks, whatever it is, it's tricky. Solenoids. I'm yet to see a case when you can't just put a double throw solenoid that you just pulse with power and it flips over to the other side. You guys may know more about it.
Yeah, we've got some scenarios where our solenoids are held the whole time.
Yeah.
Yeah, so, but not, typically not on a remote side. They have to do some kind of latching or something.
Yeah, okay. Latching solenoid, that's another word for it. All right. So one of those little magic, only remember 3 things from this talk is, if you have all these devices with diverse duty cycles and unknown power calculation figures and magic, don't bother making a spreadsheet and wasting your time on it. Simulate the panel somewhere, especially if you're going to be building 20 of the same panels. Make one, run it, let it talk to one down the hall, let Melanie build it up, and then measure the power consumption. Measure, I'm going to skip ahead. Here's some devices. This one you can buy for $20 off Amazon. It'll tell you what's the voltage in the amps, and over here it'll measure in what's that? In watt hour. How many watt hours did you use? By the time you put hour on it, now you have an energy number, not a power number.
Continuous monitoring,
Yeah.
or how much is the consumption on it?
Totally negligible.
Really?
Yeah, even that LED switch is off when you don't look at it. It kind of knows. It doesn't. Right? All right. If you spend $100, you buy this one. It'll count it up for you in amp hours, which is since batteries speak in amp hours, that's probably a more handy number for you. So you connect it. You let everything run as normal. You come back a day later, 24 hours. You look at it and go, oh, just count the hour. Now you can go, all right, I used 50 amp hours in 24 hours. Bam, now I got a number to work. Not the battery size yet, we'll get to that. But now you got a power number to work to. But if you've got to go do it on a spreadsheet and go, okay, this one, the data sheet said it draws so much, multiplied by the VS factor, divided by the time for the thing. It's all wrong, but I've never seen it work. If you can make it work, let me know. I want to see it. measure it, and measure it regularly. Own one of these, or phone me and I'll send you one. We have a drawer full of them. This is a current clamp with a 40 to 20 milliamp output. That's another current clamp. This one is one of those wall effect ones you run the wire through. $200, I think, from Phoenix, maybe something like that. It'll be 1,000 by the time we sell it to you. You would put those.
But you can put those. Is that something you would put in line like for your battery power?
Yeah, you can put it anywhere. So if you just want to measure one device, you just put it over one of the positive wires.
But since it's got a 4 to 20, you can use it as a control monitoring, like say to monitor your battery power. Because one thing we have run into, like as batteries as they age, if you have a cell go bad, and it'll sit there and just pull your power supply to death, pulling a lot of amperage, and you have no idea until you start seeing some other issues come up from it. Yeah.
Over here, where's the battery? Oh, I don't know. One of these. It goes off into the side over here.
Yeah.
You can really just pop it on the side, hang it over the thing. During the day, if you have a UPS like this, there should be no current going in and out of a battery. It's full. It's like a toilet system. If that thing is leaking, you know something's wrong with your Z. But it's a backup, right? So solar is different. Now you would know how much are you charging and discharging. But yeah, you put it there. If you see current going on, hey, something's wrong. Yeah. You're doing it fine. Okay. All right. So the point is, it's so much better to measure the power consumption. This little meter that this guy has over here, maybe $50. It's a current clamp, but it's a DC current clamp that works much the way like that other one. It's a Hall effect sensor. Your AC one won't work for DC. Get yourself one. $40, $50, bolt you on. You use that thing, keep it with you. If you really work with this a lot, phone me. I'll send you one. I'll write Solarcraft on it. Give it away.
$1,000.
Yeah, $1,000. I have given away a bunch of those because people go, and here's my this and that, and I gotta calculate this, and I go, this, don't speak. Here, let me send you this thing, and then it saves me so much money because I gotta warranty my product and go, I guarantee this thing for 5 years to perform as we discussed. Hopefully nobody can add to it. But sending one of those, the guy clamps it on, he goes, okay, it's so much. Or putting a current clamp right in the line and just let the PLC log it, and whoever makes the software, let them consider that also. How's the thing performing? How much power are we using? How much power are we using now? Put a limit on it at some point, because 6 months later somebody's going to exceed that limit. Let it ring a bell and go, listen, the UPS is now not inspecting. Okay, lights, especially in the little mountaintop kind of little houses, never put a light switch. Always put a rotary plant. Said enough about that. I worry about the time, man.
Oh, you got 23 minutes.
Oh, plenty.
Yep.
Yeah, about 5 minutes.
Yeah, 5 minutes.
I get conflicting reports.
I think you're using the Solarcraft
That's having you on. I'm enjoying it.
That's right. Multiply by.
How do y'all rate y'all batteries? I know batteries got to be probably a continuous competitive base for you guys as y'all price your packages and stuff. So you're all probably always looking at that different battery manufacturers. But when you price your packages, what kind of
No, it's too quick.
how long are you expected to see out of your battery life? Based on y'all's calculations.
If it's a UPS and you have a decent temperature compensated float charger, and it's not too hot, like say here,
Not South Texas.
no, Kuwait is bad.
Oh yeah.
Yeah, so Midland, it's not so bad either. The gel batteries do just fine.
Okay. They don't get too hot.
Midland, 3 years or so. Down here, maybe 5, or something like that.
So 5 to 10 years.
5 to 10 is a good number, yeah. We use the gel batteries from MK. We could use the AGM batteries from wherever the hell it is.
Well, I think that's what we average, 5 to 10 on most.
Yeah,
7.
7 minutes, all right. Okay.
The bar downstairs opens at 5, you got 4
Okay.
and a half.
That's a different kind of mic drop. It's like a bag. Cheers. I'm out of here. Okay. Oh man, how many times do I have to do this? All right. This one you got to put a shunt in. I have one of those at home. I've been using it for 6, 7 years all the time. $12. They never break. Get yourself one. Awesome. All right. So
800
what?
or 800.
I can see your lips moving, man, but you're aware.
He's trying to record himself.
Oh, you're talking into the camera. Okay. So, simple little example on just battery sizing. If you have 18, and I have to carefully choose the numbers, 18 watt for the PLC, 6 watt for the radio if it's always transmitting, a switch that can use more power than you think, and a PoE camera so you can look at the neighbors. 50 watt. 50 watt at 24 volt, so 50 divided by 24, close enough, it's 2 amp. How long do you want your UPS to stay up? You go, 12 hours is good enough because it's right next door. If it's further away, okay, put more battery out there. You're safe doing that. Call it a 2-day, 4-day, 7-day. People do that. So we are consuming 24 amp hours. What? Over half a day. 24 hours would be 50. This is a handy little rule of thumb. Another one of my take-home points. This has a laser. What am I doing here? If it's at 24 volt, and only if it's at 24 volt, the power consumption in watt happens to be the same number in amp hours per day, because you got to divide for the voltage and then multiply for the hours, and it's 24 and 24. So you'll know a 100 watt load burns 100 amp hours a day. So from a 100 amp hour battery, how long will it run? 1 day. When it's brand new, at room temperature, and you've never used it before. It's not the case a little bit later. Ask your cell phone. It changes. How does it change? Oh, more, okay. Duty cycles can complicate the thing, and if you go through it, you'll see it. Like DC motors that come on once in a while and say just have to keep the pressure in a leaky vessel. A little thing hissing on the side, you got to just, this motor just comes on occasionally. How much power is that going to use? Okay, even go calculate it. Or you can block the leak, and you'll be better off. Same thing, 64 watts happens to be 64 amp hours a day. Would that then be my battery size for a UPS? No. What do we have to consider? What environment am I in? You're not sizing for the average temperature. Don't go look on Wikipedia what's the average temperature for this area. You have to go pick what's the absolute worst case scenario. How cold is it going to get? Because that's when it's going to fail, and that's when your insurance is going to cost the most, and the dude in the truck's going to slide off the road and he's going to hit the grandma with a Christmas tree. It's what happens. So temperature, battery capacity, I put it here, varies tremendously based on temperature. So most equipment give you a rating at 25 degrees Celsius, which is what, 70 stupid? It's like 72 maybe, I think.
25?
Here? Yeah. All right, 70 something.
Yeah.
That will be 100% of the capacity. In summer you may get a little bit more, but the batteries don't like heat, so don't go counting on that. What is this? 32. When water starts freezing, now you're at like 80, maybe 90% of the capacity. If you work in Midland and North Dakota and straight place, Midland gets really cold. I didn't think that, but it does.
Oh, yeah.
It doesn't look it when you look at the people who live there. Oh boy. By the time you get down to minus 30, which happens, it doesn't happen here, but it happens in so many other places. you have only half your battery. So even though the air temperature might reach -40, your battery temperature is not going to be -40. It takes a bit longer for a heavy thing to cool down like that. Low voltage disconnect. You can't run a battery until it's flat. It won't live long. You still want 5 years or so out of your battery bank. Disconnected, and I got a little graph. I'm trying to rush now. Cycle duty. How often do you expect to run this UPS? That's what kills a battery. High temperatures and working. Same with me. Load size. So putting a huge load on a battery doesn't give you that capacity. So if you have a 100 amp hour battery, which is that car battery size, and you draw 100 amps from it, it's going to pull the voltage down quite a bit, deliver some to you, and you maybe get about 40 amp hours out of it. You disconnect that load, it will jump up right to that voltage. Now you can put a 1 amp load on it for 10 days, something like that. Consider the load size. End of life capacity. So by the time a battery can only hold, say, 80% of its nameplate capacity, we consider it to be dead. You can take it home, you can use it in the boat, it'll still work for the inverter and the yacht or the whatever. But for expensive assets, no, it's a dead battery. 80%, 5 years later, they'll be gone. This is a low voltage disconnect at 11.5 volts. So, man, there's a lazy here. Why do I go stretch? Look at it. 11.5 volts is an okay place to disconnect a battery. That would be what? 23 volts for a 24 volt battery bank? That is there. So if you draw the power real slow from a battery and you disconnect it at 1.9, this surface area under this is what energy still remains in the battery, and this is what you used up. This square, so you can go count it up and minus this square from that square, but you'll find it to be about 10% of the battery capacity is not available to you, and that's it. So people go, oh, disconnect the LVD. This is like the third point you got to remember and write down in your Solarcraft notepad. If you disconnect the low voltage disconnect just to get that 10% extra, because you go, I don't care about the batteries, you can always replace them, it's completely unnecessary expense. You could have just put a little bit of a bigger battery to begin with and leave the low voltage disconnect in there, because now if you don't, when you run a battery down to like 2 volt, 3 volt, whenever everything's flat and dead, you can do that like 10 times with a battery, and then you got to kick it down the road. Recycle it, that's the responsible thing. What Mr. Stuff?
Do y'all have a recycle?
Yeah. MK battery is very cool. They come pick them up and cart them around and up and down.
For us, it's kind of a dual purpose, that low voltage disconnect, because not only does it save your battery, but also in applications where you use a radio, and that radio gets to that threshold, it can stay locked in the transmit mode and sit there and just transmit and noise up your whole system.
Yeah.
And versus if you had the low voltage disconnect, it'll just take the power away from that radio.
Right.
And then that's when you realize you got a power issue, and you're going to be chasing communication problems anyway.
Because you can't talk to
Instead
it
of chasing
anymore.
the third sides, trying to figure out what the problem is, you know the one with the low power is the problem.
Yeah, that's right. Low voltage disconnects cost $20 for a good one these days. You might as well put it in there. You can. It's a little relay that clicks this way or that way. Just use it. You can signal things to disconnect, connect things, and such. This is a cycle life over time. So if you only, what would that be? Depth of discharge. Which way around is this? If you only discharge your batteries about 80% of their capacity, you can 10% of their capacity. You can get, like, say, depending on what chemistry this is, probably lead acid. Is it? Don't know, doesn't matter, close enough. 5,000 cycles out of the battery of that capacity. If you go cycle them to half, only about 1,000. So consider that this is a big deal for solar panels because they discharge and charge daily. UPSs, you kind of put them out there and they'll stay full. So for UPSs, yeah, allow a little bit for this, but it's not that big a deal. I'm almost done. This is discharge rates. So it'll if you put a small load on a battery, it'll drop the voltage down. What it should have done over here is it'll start there and then dip down a little bit, and then give you the power at the right voltage you want, and at the end it just goes blah. So the higher the load you put on, the surface area of what's under the line will tell you how much energy you can get out of the battery. At those voltages, up to a disconnect voltage, it's so little when you have a large load on it. So you got to consider that if it's just a panel that you're building, again, not such a big deal. If it's motors that you're running, actuators, pumps and such, you definitely have to remember to go look at how much energy is available in the battery at what current. Any battery data sheet should have that on. If it's not, phone us, we'll give you the right battery. Am I allowed to say that?
Yeah.
Oh. All right.
But you,
So-
in a fraction, that you said, yeah, you can say.
Okay. For our battery example, and I'll stop here. Let's say we had a 50 amp hour, or where were we at? 50? Can't remember. Yeah, depending on the time. 24 hours. D rate, if it's going to be in a cold place, drop down about 20 or add 25% for that. Add for LVD 10%. Cycle duty UPS doesn't really matter so much. Load size, panels, not such a big deal, just remember, end of life capacity, definitely about 20%. Where do we end up? 100 amp hour battery. So it's just about double what you thought it was going to be for that. If you're going to put this system in North Dakota, just put 200 amp hours, 400, just so you don't have to drive out to the pound, just because it's that expensive to do that. Probably cost as much to maintain that crappy UPS than it is to buy it. Okay, I'm done. We've run out of time. Right? All right.
We need to get in there, but I think there's a problem.
Thanks for your presentation, artwork. You got a little ticket I gave you, he's gonna draw the winner, you got a $50 gift card, one of them is gonna get.
I didn't get a ticket. No, but you got your tickets, right? It says 745905.
No, freaking way. She took my ticket and gave